Hello everyone. So we've been discussing about the colligative properties that we are discussed osmotic pressure. Okay. So based on the osmotic pressure, the comparison of two solvents. Okay. How the two solvents are going to define based on the osmotic pressure. Let's say we have solutions of A and solution of B. Okay. And this is having osmotic pressure of 1 atmosphere. Okay. So what is meant by osmotic pressure? 1 atmosphere. So with the application of 1 atmosphere pressure, you can stop the osmosis process in this solution A. So if the B is having similar osmotic pressure like A, 1 atmosphere, then these two solutions are said to be isotonic. So iso means similar. So tonic means concentration or pressure. Okay. So if phi A equal to phi, so phi means osmotic pressure. Osmotic pressure of solution A equal to osmotic pressure of solution B is said to be isotonic. Let's say the condition is changed. So solution A has a 2 atmospheric osmotic pressure and B has 1 atmosphere. So compared to B, this A is more. So this type of solutions are said to be hypertonic. Okay, hypertonic solutions based on the osmotic pressure only these values. Okay, so you can apply for the concentration also. Okay. Next, if it is lower one is said to be hypotonic. Hypo means less, hyper means excess. Okay. So these are the conditions and these are the terminologies that are used for the solutions. So in the examination, it may be given that urea solution is isotonic with sodium chloride solution. Then find out something. Okay. So find out the molecular weight. Then find out the weight. Then you can easily apply this concept. Phi A is equal to phi B. Then what is meant by phi? Phi equal to N by V ST or CST. So one CST values of A will be going to equal to the CST values of B. That is what the application of this terminal isotonic. Okay. So next, reverse osmosis. So application of excess pressure to the osmosis process so that you can get the pure solvent. Okay. So this is what RO plants, what is meant by RO plants? Reverse osmosis plants, which are used in the purification of water. Okay. So this is the latest technology which we are for the purification of water. Okay. So this is very important. So reverse osmosis. So application is purification of water. Okay. Next. So we're going to see sample questions. Okay, based on the osmotic pressure. So question is given that osmotic pressure phi of blood is 7.65. Okay, phi is given 7.65 atmosphere, and T is given temperature. Okay, and an aqueous solution of glucose is isotonic with blood. So what is meant by this? So its phi value is similar to the glucose solution. Okay, blood solution is isotonic with the glucose solution. So then find out the percentage of the glucose. Okay, so he has given the values of blood solution and asking for the values for the glucose solution. Then what you must do, if it is isotonic, so phi 1 is equal to phi 2. So what is meant by phi? So N by V CST of A equal to N by V N by V ST of B. Okay. So ST S is the can that is not going to change. Okay, so you don't need to take. So based on the variables only you need to calculate. Okay. So and T is not mentioned here. So it is you can consider at the same temperature. Okay. So what you need to calculate. So he hasn't given N by V value, but he has given phi 1 value, but he hasn't given phi 2 value, but indicated that isotonic. So pi 2 is what? 7.65. Okay. Now you need to calculate N by V value. Okay. So substitute pi 2 7.65 and does it given any volume? No. So N by V is asking, and S is 0.0821 and T is 310 degrees. Okay, 310 Kelvin. Okay, so he asked in the percentage. Okay, N by V percentage, but this N by V is in 1 liter. So if you calculate, you are going to get it. Okay, so let's say N by V equal to 7.65 into 7.65 by 0.0821 into 310. Okay, but you have weight. Okay, so what is the N equal to? It is a weight by molecular weight. Okay, weight by molecular weight. So if I replace this molecular weight is going to multiply with 7.65. So what is the molecular weight of the glucose? It is 180. So simply, so weight by volume equal to 7.65 into molecular weight, which is 180. Okay. So if you calculate, it's going to give 54.1. Okay, grams per liter. Okay, W by V value 54.1 gram per liter. Okay, but he asked for the percentage. What is weight by volume percentage? Grams, the number of grams of solute present in 100 grams or 100 ml of in volume, 100 ml of solution. Okay, so the volume will be 100 ml and weight will be in grams. So but what you obtained is weight in grams but volume in liter. So if it is for 1000 ml 5.41, for 100 ml it will be by 10. So it is 5.41 gram per volume percentage. So this will be the value. Okay. So this is one of the sample question. Okay. So here we have one more question. So 250 ml of water solution containing 48 grams of sucrose. Okay. At 300. Now initial itself it is given weight and temperature and volume. Okay. And separated from pure water by the semi-permeable membrane. What is the pressure that must be applied above solution in order to just prevent the osmosis? The amount of pressure that can be prevent the osmosis is osmotic pressure. This is what pi. He is asking pi, and given that so weight is given. So N is what? Weight by molecule. So anyhow sucrose is given, so molecular weight is given, weight is given, and volume is given. S value you can take it to 1, T value is given 300 degrees centigrade. You need to calculate the pi. Calculate the pi and send me the answer. Okay, very well. So applying itself is a big task. If you can apply everything, calculation is simplest part. So think logically how to apply. So what is required in the given conditions and what could be the result. Understand? every question will be solved. Okay, physical chemistry is need to more applicative knowledge. So if you understand what is given and what is given, then half of the question is done. Okay, next. So next important concept. So this is the best part of colligative properties. So far we have discussed the colligative properties, but what is the consequences that are happening with the colligative properties will be going to see now. Okay. So first consequence from the colligative property is abnormal molecular weights. So what is happening if you can dissolve sugar? Okay, sugar will dissolve and it will be sugar only. Okay, if you take glucose, even after dissolving it will be glucose only. There is no change in the molecular form. There is no change in the number of particles. Okay, so whatever you have taken 180 molecular weight of the glucose before the dissolution and after the dissolution, it is same. Okay, where it can be said as a non-electrolyte. Okay, non-electrolyte. Non-electrolytes means which cannot dissociate into gas, which cannot form ions by the dissociation or by the dissociation. Okay, so if it is a non-electrolyte, there is no change in the molecular weight, and we are not considered with the colligative properties as well. Okay, where there is a change in the number of solute particles by the dissolution, we are discussing that part only in the colligative properties. So let's say we have sodium chloride and weight is 23 plus 35, 58.5. Okay, before the dissolution, but after the dissolution it got into two individual particles. Now in the solution, if I calculate molecular weight based on the, let's say, molality terms. For example, if I calculate, I got the depression in a freezing point. Okay, and from that I have calculated the molality. Okay, I have calculated the molality. So let's say I have calculated molality. So what is meant by molality? Number of moles. That is what weight by molecular weight of the solute in given solvent. Okay, so if this molality is 2, the molecular weight is inversely proportional. Okay, you can see molecular weight is inversely proportional. So from the colligative property, if I calculate the molality and it got some value, let's say 180, sorry, let's say 58.5. Okay, as sodium chloride. If I take more, if I change the molarity to 3, so it's going to become, as it is a inversely proportional, it is going to decrease 58.5. So that is going to happen. So based on the molality, as we are calculating from the empirical values or theoretical values, so the molecular weight that is actually present will be differed from the theoretical value. So they will be 58.5, but if you calculate based on the colligative property, it's going to change because it is dependent on the molality, and molecular weight is going to change every time by the change in the number of particles. So it is got dissociated, so it will not be the same as 58.5. For example, if you take association phenomena, so benzoic acid generally I think it will be 120. Okay, so if it is 120 in the undissolved form, okay, or simple benzoic acid, okay, this benzoic acid if I dissolved in benzene, okay, benzene, it got associated and formed dimer. Okay, dimer based on the hydrogen bonding. So if it is forming dimer and I want to calculate the molecular weights in the solution. So what is meant by molecular weight? A molecule having the weight, okay, the weight of the molecule. So but this molecule is now dimer. It is a combination of two molecules. Now it is a dimer. So it will not be same 120, it will be going to become 240. So with the association it is going to change. So this is what differed from the theoretical molecular weight that we are considering as an abnormal molecular weight. So abnormal molecular weight will be observed on the basis of colligative properties. Okay, why it is observed? Because of molality is inversely proportional to the molecular weight. If it is colligative property is going to change, molality is going to change, and the depression or elevation in boiling point is going to change. So the molality is going to change because these two are proportional. So if it is going to change, molecular weight also going to change. Okay, that is what abnormal molecular weights. Okay, so this is what important concept. So this deviation or abnormal molecular weight need to calibrate. Okay, so for that calibration, Van has given the factor with which if you can multiply the colligative property, so it will be going to give the actual weight. Okay, so Van given the Van factor, which is indicated by I. So what is meant by I is the number of solute particles actually present in the solution. For example, if you take sodium chloride after this, so it will be in Na plus and Cl minus. Okay, so what is the number of particles that are actually present in the solution? It is okay, and number of particles, number of solute particles dissolve. So how many particles you dissolve? You have dissolved one particle, it becomes. So this is what. Okay, so Van factor will be 2 by 1, which is 2 per sodium chloride. Okay, so in this way you can calculate the number of particles or Van factor. If you multiply with the Van factor of the colligative properties, will be going to give exact values. Okay, so in other terms, the Van factor can also explain the observed colligative property, means actual colligative property by theoretical or normal colligative property. Okay, or you can also take observed molality by the normal molality. Okay, these all are proportional, so that they will be similar. Okay, but molecular weight is inversely proportional, so that theoretical molecular weight or normal molecular weight, the actual molecular weight or observed molecular weight, okay, it will be reversed. So these all are the terms or conditions or different ways of expressions of the Van factor. Okay, so after applying the Van factor, after applying the calibration factor or calibration constant, so relative lowering vapor pressure, okay, RLVP is going to become P0 minus PA by P0 equal to mole fraction into, okay, similarly depression in freezing point is delta TF equal to KF into M into I. Okay, so everywhere Van factor is going to incorporate. Okay, elevation in boiling point also similar. Okay, and similar to the osmotic pressure, which is pi equal to CRT or CST, you need to multiply with the Van factor. So pi equal to I CRT or CST, where C is the concentration or molarity. N by V here. It is not molality, it is N by V. So that concentration is molarity. Okay. So based on the observation, you can identify whether they are electrolytes or whether they are non-electrolytes. Okay. So if non-electrolytes which neither dissolve, dissociates nor associates, like glucose, so their I value will be always 1. Okay, their I value, Van factor will be always 1. If they are electrolytes and they going to dissociate, for example sodium chloride, their I value will be always greater than 1. Okay, if they are electrolytes and they going to associates, for example benzoic acid, in benzene, their Vanta factor will be always less than 1. Okay, this is very important. You need to apply for every individual electrolytes and non-electrolytes based on the question. Okay, so far what we have calculated depression in freezing point and elevation in boiling point. So that is not enough. Now onwards you must apply the Vanta factor, and you need to calculate the actual colligative properties. Okay, so how to calculate the Vanta factor for different electrolytes? Okay, so if it is electrolyte is going to dissociate, how we going to calculate? We will see. So during the dissociation, what is going to happen? One particle is going to dissociate into n number of particles. For example, sodium chloride, if it is one particle, is going to dissociate into two particles. So during the dissociation, what is going to happen? A 1 mole is going to dissociate into products. Okay, so how extent is going to dissociate into the ions is based on the degree of dissociation. This is indicated by alpha. So what is meant by degree of dissociation means number of ions dissociated by number of particles taken. Okay, so if you take 100 particles, out of that 50 are dissociated, so it will be 0.5 or 50% is dissociated. Okay, so that is what degree of dissociation. So based on that, number of particles that are forming will be decided. Okay, so if it is degree of dissociation is alpha, n into alpha particles are going to form. Okay, so total number of moles that are present will be 1 minus alpha plus n alpha. Okay, so Vanta factor, what is Vanta factor? Moles of the solute that are actually present, so this. Okay, by moles of the solute that is dissolved, this. Okay, you have taken 1 mole, but after the dissociation it is got 1 minus alpha plus n alpha moles. Okay, so if you simplify, it is 1 plus n minus alpha. Okay, 1 plus n minus alpha. Then you can also calculate the degree of dissociation alpha, which is if you calculate, it will be I minus 1 by n minus 1. Okay, just it was rearranged. Okay, I minus 1 by n minus 1. These two you need to remember, and you need to apply for the different kinds of electrolytes. For example, if I take sodium chloride, so it's going to become sodium plus and chlorine minus. Okay, so number of particles. Okay, so it is 2. N will be 2. Okay, number of particles will be 2. Okay, so this is what. So 1 plus 2 minus 1 alpha. So for electrolytes, if it is stronger electrolytes, their dissociation will be 100%. So what is meant by 100%? If you take one molecule, okay, so it will be going to give complete, one molecule will be going to give two particles. Okay, 100% dissociation is going to happen. Okay, if it is strong electrolyte, sodium chloride is a strong electrolyte, so alpha will be 100%, which is 1. So 1 plus 2 minus 1, which is 1. So 1 plus 1 equal to 2. So I value for sodium chloride is 2. Okay, so this is the way to calculate. Now you need to calculate for ClCl2 and HCl and H2SO4. Okay, calculate the I values and send in the WhatsApp group. Okay, next, what about the association? So if you can see the association, so similar to dissociation, but there is an accumulation of the molecule. So if you take n number of moles, it is going to form nth dimer. Okay, nth polymer. Okay, so if it is association, degree of association or degree of dissociation is alpha, so it's going to become alpha by n particle. Okay, alpha by n particle. So total number of moles that are present in the solution after the association will be 1 minus alpha plus alpha by n. Okay, if you simplify, I will be 1 minus alpha into 1 minus 1 by n. Okay, 1 minus alpha into 1 minus 1 by n. So alpha will be I minus 1 by 1 by n minus 1. Okay. So for example, if you take a benzoic acid, it is going to become dimer. So n value will be 2. So I value will be 1 minus. So if I can consider 100% got associated, so it is 1 into 1 minus 1 by 2. Okay. So this is 2 minus 1 by 2. So it is 1 by 2. So 1 into 1 by 2. So it will be again 1 minus 1 by 2. So overall it's going to become 0.8. Okay. So just calculate and check. Okay. So this is the way to calculate the associated. Okay, associated particle. So generally in your syllabus only dissociation are more prioritized and more number of questions will arise from the dissociation. Okay. So more focus on the dissociation. This may be asked directly formula type. Okay. So this is what the theoretical colligative property. Okay, complete theory. So last one will apply this concept, Van der factor concept to this question. Okay. So molar elevation constant Kv is given for water is 0.52 and molality is given 0.1 molar. So for the solution of NaCl, the Tv, okay, boiling point will be, so delta Tv equal to Kv into m into I. So what is the I for the sodium chloride? It is dissociated into 2 particles. So its I value will be 2. Okay. So based on the above calculation, just now we calculated. So based on the above calculation, I value will be 2 and molality is 0.1 and Kv is given that 0.52. So if you multiply this is 0.5 into 2, it will be almost 1. Okay, 1.04 into, so it will be 1.04. okay, sorry 0.104. okay, 0.104. So as the boiling point of water is 100 degrees centigrade, so delta Tv will be Ts minus T0. okay, so Ts we need to calculate. So this is given 0.104. so if you add T0 to this delta Tv, it will be going to give Ts. So 100 degrees is the boiling point, so it will be Ts will be 100 plus 0.104. so that is what option D. Okay. So now onwards, if it is given dissociative associated particles and electrolytes, you must apply the Van der factor value. If it is non-electrolytes, you need to you can omit this I value. Okay. So this is about the colligative properties. I will send the questions. You need to work out and you need to write the solutions and send back. Okay. Thank you.